Като експортован на Slovenci hitro zadovoljen, zdaj če bo šel potem, ko se počasi. Vse, ja, če, oh my god, da se posem to malo, ko sem. Da malo, ko sem tak simulacijo, da hitrost na Jurija.
50-50 malo, da gre desno.
Ja, 50-50.
Zakaj se to skozi premika? To se mora. Možno lahko poklikati, da se premika. Fui da cadela, pare.
Mama dela
Špela sprašuje, kje ste stanek morali?
V dekalo.
Pravi čigumir. Kaj je čigumir?
Kako está, Tommy? Mira, esta es lo que estáis viendo ahora mismo, esta es más típico de trabajo. La más típica es
¿Cómo recrear? Porque tiene que del reloj.
Riha will come, Tommy will come in just a moment. Hi.
Tommy,
Yes.
could I start? Start.
Okay, can you hear each other?
Okay?
Okay.
Start.
Hi, my name is Aroa,
And my name is Jasmine.
and we are going to show you the project in our smart city that we have been doing for 3 years.
Today, each person will explain his work, and we hope you like it.
Hello, we are from robotics class from third year E, and we made a solar panel named Midas panel. And I'm Adara, and I'm going to explain why we picked Midas panel as name. We first took it because a team named Midas loved gold. So for us, the goal is because its middle panel has all of our first letter names. A for Maria, E for Elena, D for Daniel, A for Alana, S for Sergio, P for Pablo, A for Alejo, N from Nayara, E for Elena, and L from Leandro. Hi, I'm Alejo, and I'm going to explain the proposal for this project. Our first proposal is a prototype for version 1, which works with switches. And the second proposal is version 2, which will work with light sensors.
Hello, my name is Irene, and I'm going to explain the components you can see in our solar panel. We have 2 motors to move the solar panel, 2 motors driver to move the motors easily, switches to all the different movements, wires and resistances to connect and protect all the elements. One Arduino board is the microcontroller board, where our programs is to control the solar panels. And the proto board, it is the board we use for our prototype. We use it to connect all the elements.
Hello, I am Leandro. I'm going to talk of the performance of this project. The project Midas panel works with 2 motors. The motors move the solar panel upside down and left or right. There are 4 buttons. They control the rotation direction, left to right, upside down, frontward, backward.
Good work.
Thank you.
We have programmed the UnoBoard to detect an object through a distance sensor, and depending on the distance, activate the movement of a stepper motion.
When an object approaches the sensor and this distance is less than 5 centimeters, the program gives the order to move a small stepper motor.
We have made some movements of 90 degrees in one direction and 90 degrees in the opposite direction to make that the object is always in the same starting position.
The oil that is moved by this motor has been timed on a series time, as we are to call the containment.
job. Anda, los de segundo. Faltan los de segundo. Si quieres que vayan pasando.
Oye, que no saluda. Uy, cuánta gente. Uy. Parece que están todos ahí. Uy, que me cagué.
Ah, que yo también me parezco. Vamos a ver. Yo que fui.
Prepárate.
¿Sabes qué te pasa? Que no me...
En inglés.
Ajá. ¿Lo has preparado?
No.
Sorry for delay.
Oye, ¿por qué se van a hacer proyecto?
Hello, my name is Beatriz. I am 13 years old and this is my project. My project is to automatic doors, like those in supermarkets, in which is an object of, for example, one mouse nearby. Both doors open and they stay open for a moment and a green light turns on. When they close, a red light turns on and the green light turns on. When the green LED is on, it means that the doors are open, and when the red LED is on, it means that the doors are closed. As you can see, the materials used are a cardboard box, an ultrasound sensor, which is similar to a motion sensor, and like a traffic light, which are three red, green, and yellow LEDs. Inside the box, there is an Arduino, which is the component that sends the programming orders. There is also a protoboard, which is where the cables and resistors are connected, a motor step by step, and connected to a driver, which is what makes the doors move with the help of an elastic. And to make my project work, a USB cable can be used and connected on one side to the Arduino and on the other side to a socket, or it can be connected with a battery directly to the Arduino. And to program the Arduino, I have used the Arduino blocks, which is a website for programming the Arduino. On this website, I have programmed the ultrasound sensor, and the motor, and the different LEDs. Each of these elements are seen as different things.
We can technical problems, but this project is very nice. Por el ruido. Con el ruido, a veces estamos en el comercial de to see the next project, and we prepare the first one quiet.
Hello, I'm Andrew, and I have made this helicopter. If I press the button, the helicopter starts to spin, and the light turns on green. If I put my hand on an object close the sensor, the light changes to orange, blinks, and the helicopter spins and stops, spins and stops. And if I press again the button, the light changes to red, and the helicopter stops. And if I press again the button, the helicopter starts to spin, and again change to red and stop to spin.
Okay? Thank you, Alvaro. Will we see this? Now. No va. We have several technical problems. We can see the next one. Javier. Please. Beatriz, déjalo que él pueda. ¿Llegas o no? ¿Tienes que poner la otra pinza? ¿Cómo? No me entero. Ah, vale.
Indeed, I have been working on the wheel, which spins thanks to the DC motor, and it also has an infrared sensor here, which detects how many wagons pass in front of it. And the Arduino and the motor driver controls the system. And I have also put a LED strip and an LCD screen to make it more good. The people are going on the ground, entering the ground, and when all the wagons are stopped at one time, it spins for 20 seconds. that's it.
Thank you very much. What do you want?
Hi, I'm Jorge Garcia, and this is Sony. It's like a counter attraction, and it has a touch sensor that starts the program, a servo motor that moves the barrier, and a stepper motor that controls the swing.
Nice, good job. Thank you, Jorge. Disconnect. Thank you. The next one. Venga, Cristina. ¿La veis? Hello.
Hello, my name is Taylor, and my name is Sophia. We have made a store was metal barrel, freeze and false when we place a barrel. Then my partner will explain how it is. We have the bottom 2 to be the one that goes up, and we have the bottom 3, and what is the one that goes down. So then we press the bottom 2, the barrel will go up, and when we press the bottom 3, the barrel will go down. This works thanks to an engine that we have programmed through a program called EuRoB+G. This engine connected into a PC by means of a cable will work, and when we have loaded the operation code. Okay, thank you. Cristina. ¿Está conectado? ¿Dónde lo conecto? Okay. Explain your project. Hello, we are Cristina and Carla. We're going to show you our project. Our project is a lighthouse. When you plug the battery, the blue light comes on. Then the light spins, turns one and turns the other side.
Okay, thank you. Good job. This one? No? So we can see, Aroa, can you explain your project? Sí.
Hi, my name is Aroa, and I've been doing the drawing, but due to technical problems, it doesn't work like it would have to do. At first, I was doing it in a bigger size with a classmate, but due to COVID, I did it alone, but in a smaller size. It will have to work in this way. When the motion sensor detects a robot, the drawbridge goes down, the barrier rises, and some green LEDs are turned on. In the same way, when the other sensor detects a hand, which pretends to be a sheep, the drawbridge rises, and the barrier goes down, and some red LEDs are turned on.
You can see the legs change the color, but we have problems with the motors. Thank you, Aroa. Álvaro, please.
Hello, I'm Alvaro, and I made this small lift as a project. I made a smaller version than the big one of the city because of the COVID. And my teachers and I thought it would be a great idea to make a smaller one. So here it is. The lift has 3 sensors, one for detect the position of the lift, and the other 2 for detects if there is a road on the first floor or if there is a road on the second floor.
¿Está conectado? A la derecha. Si trabajan los dos, ¿recuerdas?
If there isn't a road on, if there is a road on the second floor and the lift is on the first floor, the lift go up, then wait a few seconds, and then go down.
Thank you. I think we can see the door now. It's a nice project, but in the direct now look. Now the doors is closed again. Thank you, Beatriz. It's a good job. Okay, this is all. This is all our job.
Okay. Thank you. Now we will start with our part of presentation. As first, Lara, Max, and Matic will present their way to prepare robots for and materials for workshop.
Lahko, ja. Aha, zdaj bi lahko, če bi PowerPoint videl, ne? Delavnica tole. Čas delati danes. Prva?
Tukaj imamo kamero predavnico. Se tisti samo kaže stvari, ki govori. To sam čekaj malo, da... Ja, mislim, da je blur.
Ja, ja.
Vida preto. Ja, ne ga da. Moj brat. So, if you remember from Monday, we use this PowerPoint right here that we actually translated from Slovene into English, so that we could better explain how the inner workings of the EV3. Okay, and we also send you the instructions to build this sensor module. So, we took a picture of every step and then just put those pictures in a Word document and edited them so that it could be easily understood by you. And then we also helped you to assemble them if you had any questions. We also use the EV3 software and their inbuilt teaching suite. So where we took the examples so that we could use them to teach you how to program the robot. And then we also on the build we also different policy fields so that the robot knows how to orientate on the field. The black dots, the red dots right here tell the robot how to move. So the left sensor picks up red at the left or at the right. Sensor picks up red at the right.
Because then you don't want to sleep in. Yeah.
Okay. If both sensors pick up red, the robot can choose either go left or right. It has 50% chance to go in any direction. When the robot sees with both sensors green, it will stop, wait for about 2 seconds, and then drive till it sees green again, and then continue following the line. And lastly, we also put in brown, so brown is essentially endpoint. The robot knows that he arrived at the garage, and after that there's lights in the garage. So the robot will turn right because it then right is right sensor. And you can also see that he stopped at the green and goes till the next green. That's we demonstrate how it acts when it comes to brown. And when the next brown will just drive under the garage and wait to do something else. This will be all sides.
Hazırlar Nets.
Yeah.
Netsy. Yeah.
Hello everyone. I'll tell you a little bit about how we built this model of the city. So we are a bit short on time, and we decided to only build, recreate a part of the city that you built in Spain. We built 3 buildings: the garage, the municipality building, let's say, and the lighthouse. And those buildings are connected by the roads, which are pieces, lines of black tape, which are in contrast with the white surface, as you all know, black surface reflects less light than the white one, and that enables the robot to follow the line nicely. And then, as you've already heard, those colored pieces of tape are for the robot to stop and decide which way it wants to go, or if it needs to stop at the zebra crossing. And all those buildings are made from recyclable materials. And I think that's more or less what it is to say about it.
Thank you. Nets. Now Leon will present his 3D model of smart city, how he built it and how he programmed it. Yeah, no. Yeah.
Okay, hello everyone. My name is Leon, and I created the 3D simulation for our future city. The whole simulation was created in Unity. This is a free 3D software to program and create games, animations, and art. So this is our end result. It's the city where our robot, which you can see on the here on the bottom, is driving around, and it automatically chooses where he's going. He can also go to the garage that you can see here in this corner, and here is also a slow part where he has to slow for the time he's on this field. Everything works completely automatically, so he decides where he is going. We also have traffic lights. They turn red and green, and he has to stop, of course, when the red light is on. So he doesn't go to the garage every time. It's completely random, and he goes to the lift and goes on the top. So how we created this simulation. Here you can see the interface of Unity. You can see it looks kind of complex, but it's pretty simple. It's out of different parts. So for example, here on the bottom, you can see the project window. Here are all the folders and the data that you use to program. Then you have, for example, a folder of materials, scripts, models, and so on. Then we have on the left side the hierarchy. This is a space where we have different objects, and it's a list of objects that we are using in the scene. And when we select a certain object on the right side in the inspector window, we see the components of its object, and we can control them. For example, the transform is a default component that controls the position, rotation, and scale of an object. On the bottom, we have a console where we get the feedback whether our script is working right or wrong. And on the top, we have different windows for scene and game view. The scene view is the view we are working with. Here we can also see different waypoints that we are using, so we can orient a little bit easier. And we have the game view where we see the finished product in real time. So for the programming, we used Visual Studio. This is a program for writing scripts, and it's free, made by Microsoft. For example, this is a script for our robot's movement. And we also used Blender for modeling. This is a 3D free software for modeling, and here you can see our models before they were imported into Unity. So our process looked like this. First, we created the scene where was everything very basic. We had different points. You can see those red points. These are the corners and the spots where our robot has to turn, and one is in the middle. So this is the script for our robot. He has two positions: the moving spot and the last spot. The moving spot is the spot where he's going to move. This was we call the spots the positions of our red objects that you can see on the next slide, and then he moves to them. Here is and each spot controls the next spot. So every script is connected with each other. So we have to take care that every spot is connected correctly. So for example, our robot is on the bottom and he goes to the corner. So he has only one option to turn right and go to the, we call it a T spot because it's in a shape of a T. If we look at the two pink and one blue arrow. So our robot needs to know from which direction he came and which two of the next spots are available for him. So he can go upwards or into the center. And in the center, he has to randomly choose between 3 different spots to move. We also added traffic lights. They work very easily because they can be controlled automatically or manually. So automatically they change green and red light between 8 seconds, and we can also use the automatic mode where we can also click on green or red light button to change the state. Then we added the different objects that are core for our city. First, we added the garage. This is the rough model, and the lift where he goes up and down. This is the script for our garage. It's very simple. We use different spots, and we created a path where our robot has to go when he enters the garage. And we also had added this slow part where the robot needs to slow down. Then we, for the end, we added the models from Blender and created our beautiful city. And here you can see our robot on the top of the garage when he's parking in the parking spot. And then we also added the main menu and the about menu, where we can see also the different informations about the project and how was the simulation created. Thank you.
Thank you. Now we can open a little bit exchanging experiences. Maybe Jaka will tell us about his view of that project.
I believe that we all have gained a lot of experiences from the project. We learned how to properly work in teams of different groups, and we've learned how to use teamwork towards our advantage. Also, a great experience was when we learned how to connect two schools from two different parts of Europe and execute the project without a bigger problem, despite the language barrier. Even though the language barrier was present, because none of us are the perfect English speakers, and but despite that, we all understood each other, as in Spain. We understood each other. We understand each other right now, we finally finished the project. One bigger problem, one of the biggest problems, was also the COVID-19 that was present in Europe for the last 1.5 years. But we all went through the experience and finished the project after about 2 years. My part of the project was to build a garage house and the clock tower, and with the help of the other students, we've managed to build the entire city because we connected and we communicated with each other. So in a sense, we can all agree that communication is the key to success in teamwork, and without it, nothing can be achieved. So that was a great experience for me, and I would do it again if I could.
Thank you, Jaka. So, Eva, we have finished our part of presentations. If you have any questions, please ask.
No questions. No questions. No questions.
No questions?
No questions.
Okay, then we can prepare for meeting with authorities. Now it's you did a very good job with those electronic parts, and fortunately we can't assemble it in our model of city, and it's was the main goal of the project, but we can't realize it. Maybe next time, maybe in the future we will try to come together and try to make a real model of city.
We're waiting for Emma to come, since she's looking for her mobile phone. So if you need her for something, just let us know, and we'll try to reach her as soon as possible.
Vem, qual é você tá?
Nice, no?
Ella is about to come to class. She's going up the stairs.
Hello, Tommy. I am here again. Sorry, because I have a problem with my phone. Oh, Dios mío, me he olvidado. Me he olvidado de ti, lo siento. Que ya he terminado la exposición. We have a break now. Hello? Tommy? Your micro is off. I think. Could you hear me? I can't hear you.
Now we can hear each other. Okay.
Okay.
Something went wrong with my computer, so.
Don't worry.
Yes.
The dialogue.
As I said, I think that your students made a great job with this electronic parts of our common city, and it's a pity that we can't do it here in Celje and to complete our model of city and reach the goals of our project.
Yes, it's true.
Unfortunately, that is our destiny.
Yes, but we have done the best we can in this situation, I think.
Yes, yes.
We can't we can't do anymore, I think.
I know. It's really. Maybe in the future we meet again and maybe we will complete this model. And as you said, you will have that model in your classroom for the next years?
Probably.
Mm-hmm.
I try, but I don't know if my headmaster allows.
Yes. Mm-hmm.
Because it's the smart city use a lot of space, and I don't know.
Mm-hmm.
I try. Okay.
We also won't throw it back and throw it away from ours. We will use it in the future for learning, programming, and as a sample of a model.
Yes. Yes. Okay.
Okay.
Well, we have now the break.
We can have a break, yes, and we meet again at 10:30.
Yes, we come back with the authorities. Yes, and I don't know if you must allow the ghosts enter, no? When they try to connect to the at the link.
Yes.
You send me.
Yes.
You must allow to access or no? Or they access?
I think no. I think it's automatically on. Yes.
We have 4 or 6 bots from authorities.
Okay. So at 11:15 we'll meet again.
Okay.
Okay. Maybe a few minutes. Maybe a few minutes earlier.
Yes.
11:10.
Okay. Yes.
10 past 11. Okay.
Yes. Okay.
Okay. See you.
See you.
Bye. Tako, ja.